Title: Day's Light Scattering Experiment. Scope: Determination of true nature of light by diffraction, refraction, and dispersion of different lasers, and correction of previous assumptions and conclusions about characteristics of light and its spectrum. Place: Pune, MH. Date: 15/11/23 to 20/11/23. Performed and recorded by Air. Gopalchandra Pradeep Day. Aim: 1. To prove that red light scatters and deviates more than blue light. 2. To observe color shift of different lasers through a prism of refractive index 1.57. 3. To determine true nature of light, forming equations based on practical results and simulations. Apparatus: red, green, and blue/violet laser, white light source, sunlight, equilateral prism, diffraction grating 300, 600, and 1000 lines/mm, 2 stands with mount/2 clamps or bench vise, screen, scale/measuring tape, marker/pencil, recording instruments. Part 1. Procedure. A. Clamp the diffraction grating onto a mount and keep at a fixed distance x cm from the screen. Make sure that the diffraction grating is clean, parallel to the screen and perpendicular to the base. Base and screen must be perpendicular. B. Set up another clamp few centimeters behind the diffraction grating in such a way that the lasers could be replaced easily. Make sure that the laser beam is perpendicular to the diffraction grating and the screen. C. Shine the laser through the diffraction grating. Light will split into separate beams after diffraction through the grating. Repeat with the other lasers. D. Mark the spots that the beams create after deviation and measure the distance of the deviated beams on the screen to the datum beam. Diagram. Observations. Fixed distance x equals 40 centimeters. Red laser deviates by 30.4 centimeters using 600 lines/mm diffraction grating. Green laser deviates by 22.3 centimeters using 600 lines/mm diffraction grating. Blue laser deviates by 16.2 centimeters using 600 lines/mm diffraction grating. Calculations. I, theta alpha equals tan superscript 1, dz/x equals 37.235 degrees. 2, theta beta equals tan superscript 1, dy/x equals 29.139 degrees. I, theta gamma equals tan superscript 1, dx/x equals 22.048 degrees. Note: red light deviates more after diffraction/refraction through a denser medium than green light, which deviates more than blue/violet light. Therefore, angle of deviation of red light is greater than green light, and angle of deviation of green light is greater than blue light. R degree G degree B degree. Images: diffraction of different lasers. Theory: an interesting observation was made after multiple calculations. The triangle formed by the deviated rays of any 3 different waves of light has at least one altitude as 11.5 cm irrespective of side lengths and angles of the triangle. It is a constant. Also, if red dz is taken as the base, then height of the triangle is always less than the shortest side. Blue dx is always the shortest side. Green dy is between the two. Diagram.
I dz dyspros dx. 2 dz dx dyspros. 3 r symbol stopnia 90 symbol stopnia. For reference, r symbol stopnia is opposite to dz.
The triangle formed is always an obtuse scaling triangle. The rate or factor of scaling of the angles of deviation are 1.24, 1.27 of green WRT blue, 1.32, 1.35 of red WRT green, and 1.67, 1.73 of red WRT blue. These values can be considered as refractive index of blue, green, and red light, respectively. The reason for distortion or scaling, shortening/stretching, of image is the varying ratio of angles of deviation between 2 different color lights. Red light will undergo total internal reflection before green light, which will undergo total internal reflection before blue light. A slight identical change in position of red light and blue light causes red light to deviate much more compared to blue light. About 33 to 39% more. In case of blue and green light, the deviation increase is about 5 to 9%. In case of green and red light, the deviation increase is 25 to 32%. Red shift means object is approaching the observer or observer is approaching the object, or both are approaching each other, or one is approaching the other with a positive relative speed irrespective of absolute speed. Conclusion. Red laser deviates more than green laser. Green laser deviates more than blue/violet laser. Blue light scatters the least, green light scatters moderately, and red light scatters the most. Compiled and masked image, RGB. General equations of light, equations only no derivation. Psi equals x/del t, sine f del t, y, plus or minus del t, plus or minus cosine f plus or minus n del t x, plus or minus del t, plus del t m/s, superscript 1. Lambda equals f del t, y, m, superscript 2, lambda equals f plus or minus n del t x, plus or minus del t, m, wavelength, superscript 3. X equals amplitude m, del t equals change in time s, f equals frequency hertz, x equals displacement along x-axis m, y equals displacement along y-axis m, k equals resistance factor, n equals x superscript 1, and n equals y superscript 1, n equals wavelength factors.
X ligu X log T ligu dis ligu S ligu XK, X plus I, I ligu X log T ligu dis ligu S ligu IK, X plus I, MM.
Is an element of equals m integral psi dot del t kj. Is an element of equals m, 2 pi x square root, z superscript 2 dash, x superscript 2 plus y superscript 2, plus pi xy, log, t, plus tkj. Is an element of equals energy, log equals ln, natural log of function. Tau equals magnetic and electric field lines, phi equals magnetic flux density, epsilon equals permittivity, psi equals permeability. S equals is an element of delta is an element of t slash v goes m. S equals distance traveled by light m, d equals voltage slash potential of source or charge available for transfer at source EV, I equals current or rate of flow of charge a, t equals time s. Delta is an element of equals increment m beside kgm superscript 2 slash s superscript 2. Is an element of equals initial energy, plus or minus delta is an element of equals gain slash loss of energy, increment m equals change in mass, v equals velocity of object wrt direction of propagation of light or relative velocity, psi equals wave equation of light, increment m is proportional to vit. Alpha equals 0 meters per square second, acceleration of light equals 0 meters per square second. Z equals distance between source and observer slash object or total distance covered. Complement equals infinity m slash 0s. Infinity equals instantaneous arrival is not equal to infinite velocity. Light takes same time to travel different distances. Velocity of light is constant and always at peak. Its velocity is the same as the rate of expansion of the universe. It is different at different locations in the universe and near massive galactic objects like stars and black holes. Here near Earth, the rate of expansion of space is 3x10 m/s, so speed of light is 3x10 m/s. Rate of expansion of space depends on mass, density, and energy of object. Rate of expansion of space cannot be calculated, but it can be observed directly. Speed of light is not consistent throughout the universe, but it is constant in a given domain of reference frames where density of objects do not fluctuate frequently and average density of objects in the domain under observation, is consistent. Part 2. Procedure: shine red, green, and blue lasers through a prism. Observe the color of laser inside the prism and the colors before and after refraction of incident and emergent rays respectively, returning to original medium i.e. air in our case. Observations. Red laser after refraction remains red in the prism if the laser is powerful enough, i.e. it should have high luminosity / power output / amplitude. If not, then no laser is seen in the prism. 2. Green laser turns red after refraction in the prism and turns back to green after exiting the prism. 3. Blue/violet laser turns green inside the prism and turns back to blue/violet after exiting the prism. Special note: violet laser turns blue on reflection on few white/transparent surfaces. In fact, it gets brighter, which means it has more momentum than other lasers and can charge the surface it is falling on. Images: compression and refraction of light in prism. Conclusion: light compresses while traveling through mediums and conserves momentum by color shifting and increasing energy potential of medium. Image: dispersion of sunlight through prism. Did you know? The sky appears blue because cosmic, gamma, chi, UV rays compress to violet, blue, indigo, cyan light and they deviate and scatter the least. Sky appears red and orange when green light compresses to become red and or when blue light compresses to green and this green light compresses furthermore to appear orange. This happens at critical angles of refraction when sun is at high obtuse angles with respect to observer on Earth's surface, causing prism effect and due to high refractive index based on Earth's atmospheric layers, volume, varying density of air with altitude, wind and composition, temperature, pressure, and sun's position. In such conditions, most of the light is reflected back from the Earth's surface. This is another reason for the cooling effect in the evening. It is hot during the afternoon as not much reflection takes place and the Earth's surface absorbs most of the sun's radiation. The aurora or northern lights are another example of impression of long wavelength cosmic radiation.